So today's topic I'm discussing about is the electrolysis. Before I start the topic of electrolysis, can you tell me what is the meaning of the electrolyte? Yes, can you tell me what is the meaning of electrolyte? Please answer me something, whatever you know. Non-conductor in solid state. Very good. Complete your answer. Very good, yes. But it's a conductor in the fused state. Very good. Or in the aqueous state, right? Fine. So the substance, all of you students, see here, that the substance is a non-conductor, a bad conductor in solid state, but it is a good conductor in the molten state or in the aqueous state, right? In the molten state or in the aqueous state. So suppose I have an example of a sodium chloride and I connect it with a battery, right? And here I put up here an instrument that can measure the conductance. Let it be, it's a voltmeter or a galvanometer or an ammeter or even simply LED, whatever that can measure the conductance. This does not show any conductance. This sodium chloride does not show any conductance. But the same sodium chloride, if it is heated, it gets converted into their ions, Na positive and Cl negative ion. Right? So here I have Na positive and Cl negative ion. And here I am passing the current now. And here I put up here instrument that can measure the conductance. These ions move towards the oppositely charged ions, negative ion towards positive and positive ion towards the negative. Getting me? So this sodium chloride is a conductor in the molten state, but not in the solid state. Getting me? Yes, friend, are you getting me? Right. What about my other students? Okay, yeah, good. So this is the negative is the cathode here and anode is the positive here. Right? By sign convention, negative is cathode and positive is anode. So what happens at cathode? The sodium ion gain electron and become sodium here. Right? Basically, it's a process of reduction. Gain of electron is reduction. And at anode, these chloride ions lose their electron and become chlorine atom, and two such chlorine atom combine to form here Cl2. Two such chlorine atom combine to form here Cl2. Getting me? Right. So chlorine is liberated here. So the whole phenomena is called the electrolysis. We can define the electrolysis like this. It's a phenomena of passage of current. Right? In the molten or an aqueous state, which is accompanied by what? Reduction and oxidation and production of substances at cathode and anode. Right? Are you getting me? Are you clear? Right. So we'll be discussing this electrolysis in two different aspects here. One is a qualitative part. Electrolysis we'll be discussing in two aspects here. One is the qualitative part. Means what product will be formed at cathode and anode. And the second is the quantitative part, how much it will be produced. So this electrolysis topic we are going to discuss in two different aspects today. One is the qualitative part, other is the quantitative part. In the qualitative part, we'll be discussing uh, what product will be found, and in case of the quantitative part, we'll be discussing how much it is being formed. Right? Getting me? Yes. Any doubt till now? Yes, Neha. Any doubt? Okay. Yes. Okay. So we can now basically understand like this. Yes, if I ask you, what did you take in your lunch? Neha, a question to all of you. What did you take in your lunch today? Please give an answer. Okay, dal. Okay. Roti dal. Okay. So this is the qualitative part of what you ate, what you took, right? You took roti, you took dal, you take sabji, all that, right? What do you call? This is what you took. But my question is, how much roti? That is the quantitative part. 2, 3, dal, how much? Right? 2 plate, sabji, how much? Something like this. Right? That is quantitative part. And what you ate is the qualitative part. Are you getting me? Right. So this is we are going to discuss about it now. First of all, I'm now discussing about qualitative part now. In the qualitative part, I'll be discussing here what are those factors which affect the product formation. So these are the different cases, factors which influence the product of the electrolysis, right? So number one, we'll be discussing here molten or aqueous, acid-related water, copper sulfate solution containing platinum or copper electrode. So different cases I will be discussing here. Getting me? First of all, I have taken the example of the molten NaCl, right? Nature of electrolyte, concentration, current density, and yes, what are you asking? Can we use base plus water in the third? Not exactly. I'll tell you how. So these are the different factors on which the rate electrolysis product depend. Number one, nature of electrolyte. Number two, concentration. Number three, current density. And number four, nature of the electrode used. So I'll be discussing all these one by one. First of all, I am talking about the concentrated sodium chloride aqueous solution using platinum electrode. When I say platinum electrode, this is inert. This is inert. Aqueous means when dissolved in water. Sodium chloride. So here we have a sodium chloride and water. It can dissociate into Na positive and Cl negative, and water dissociate as H positive plus OH negative. Getting me? When I pass current at cathode, what is the charge on cathode? What is the charge on cathode? Respond here fast. Neha? Yes, negative charge. So on this negative charge electrode, the positive ions will be attracted. Means sodium ion can gain electron and become sodium positive. Or it may be possible that the H positive ion can gain electron and become H atom. And two such H atoms now combine to form here H2 gas. Right? Getting me? Any doubt here? So either the sodium will be deposited or the hydrogen will be liberated. Which will take place? Do you have an idea which will take place? I say one of the two will take place. Either sodium will be deposited or hydrogen will be deposited. Yes, how do you know that it is the first one? Why not the second? Why not hydrogen gas be liberated? Yes, students. Activity series. Okay. Any other case? Any other example? Any other reason? No. Anybody else who can give any answer? Neha? I guess you don't. Please don't guess. Be very very sure. Yes, Akash. Okay, I tell you now. What happens here? If you see the reduction potential of sodium, that is equal to minus 1.37 volt. And if you see the reduction potential of hydrogen, can you tell me what is the reduction potential of hydrogen? Can you tell me what is the reduction potential? Yes, yes, 0. I get the 0.00 volt. Now, can you tell me which is having higher reduction potential? Which is having higher reduction potential? Second. So, which will take place? Whose reduction will take place? Hydrogen or sodium? Hydrogen, right? So, hydrogen gas will be liberated, sodium will not be liberated here. Are you getting me? Yes, are you getting me? Everyone? Now, I go to the anode part here. When I talk about the anode part, I have two things. One is the chloride ion, other is the OH ion. Which will be discharged? Either chloride ion will be discharged, one possibility, and two such chlorine atom combine to form here Cl2. One possibility I'm now talking about. Second possibility is the OH ion. These OH ion can be now going like this. Clear? Yes, now I'm coming to your answer first. Everybody? Yes is asking sodium has more reactivity than H positive ion. So hydrogen should be undergoing reduction. Yes, if you know the reactivity means it is related with how easily it loses electron. You're right here. Sodium is more reactive. It means that has more tendency to lose electron, but not to gain. It is the reverse is happening here, right? Sodium is more electropositive. Yes, it is not gaining electron. It is when you say reactivity or electropositivity, that is sodium is more reactive. You're right, but that is the case of the losing electron, not gaining electron. Here we are discussing what the gain of electron, right? Okay. Now, at anode, either chlorine or the oxygen will be liberated. Now tell me which will take place. Which will take place? Why second? Why not first? Yes, you give you a very quick answer, but I know I want the correct answer also. Speed and accuracy both. Very good. Preferential discharge theory. Very good. So what does it suggest here? This theory suggests that ion will be discharged. I'm using a word discharged, means charge is lost. If the OH ion is negative here, now it is neutral here. The charge is now discharged, that will be requiring less potential. We are passing current of certain potential. The one that will require less potential will be discharged first, right? So maximum discharge potential is for the sulfate ion, right? Then it is for the nitrate ion, NO3 negative ion, then OH negative ion, then Cl negative ion, then Br negative ion. I negative ion. This is the decreasing order of the discharge potential. Which require less potential to get discharged? OH ion or the chloride ion? Which require less potential to get discharged? Chlorine. So the chlorine will be discharged, OH ion will not be discharged. So chlorine gas will be liberated. It is not the oxygen gas. Are you getting me? Everyone? Right. Fine. Perfect. So you must be very careful what is being asked, whether it is a concentrated or the OH ion. Right. Just leave it. This we have already discussed. Now, I'm not talking about the dilute case. Case of dilute, NaCl. Dilute NaCl. Dilute means battery also involves electrolysis. Yes, yes, yes. Yes, Anirudh. Batteries, and I will discuss all the battery case also. There's the last topic of our chapter, that is the batteries. Right? I will discuss that part. Right. So whenever I say dilute, what is the meaning of the term dilute? Yes. Everyone, what is the meaning of the word here, dilute? Under what condition you say the solution is dilute solution? How much low? Akash, how much low? Up to what concentration you will say it is a concentrated solution and then it is a dilute solution? Any idea? I told you in the chapter of solutions. No, no. No, Akash, 49% is not. 98% absolutely not. Okay. It is the 5%. It is 5%. Below 5%, it is dilute, and above 5%, it is concentrated. There is a demarcation line. Please keep in mind, 5% is the case. Right? It is by the sign convention. It is by the convention only. Right? In chemistry, we are just considering here that 5% or below is a dilute, and after 5%, it is the concentrated. So, when I say dilute NaCl, it means the amount of the sodium ion or the chloride ion is very, very less as compared to the H positive ion or the OH ion. Right? So, when we pass current at cathode, I have both the possibilities. One possibility is H positive can gain electron and become hydrogen. Other possibility is sodium can gain electron and become sodium deposit over there. Now, which will be gaining electron? Which will be gaining electron? Hydrogen or sodium? Anirudh, why sodium? Yes, justify your answer. Why hydrogen? There is two reasons. I'll just say that hydrogen will be there. Number one, the concentration of sodium ion is very, very less. It means around the electrode, the sodium ions are very, very less. It's a dilute case. Number two, hydrogen has more reduction potential. I told you, for the hydrogen it is 1.37, and for sodium it is minus 1.37. For the hydrogen it is 0. So hydrogen gas will be liberated, not the chlorine. Are you getting me? Yash? Akash? Neha? Everyone? Right. Now I go to the anode part now. Now let me know what will be ready, what will be discharged. Cl negative ion or the OH negative ion? Yes, Ruja? Yes, Ruja. Which will be discharged? Which will be discharged? OH ion. Why, Anirudh? Yes. Why so? Because the OH ion concentration is very, very low. Right? And even though the Cl negative ion has less discharge potential, but they are not available around the electrode. Now, whatever is available is a OH ion. So these OH negative ion will be discharged. It will form here water and oxygen and electrons. Are you getting me? Yes, are you getting me? Right. So you got it, the difference between the concentrated case and the dilute case. In the concentrated case, at the cathode it is the hydrogen, and at anode it is the chlorine gas. But in dilute case, we can see at the anode, instead of chlorine, the OH ion is liberated. Oxygen is liberated. OH ion get discharged. Right? Clear-cut difference should be there. So while solving the multiple choice questions, please see to it whether it is you are being given the concentrated case or the okay. In the previous two cases, I have discussed the platinum electrode. I have discussed the platinum electrode, but now I am using here the mercury as a cathode. Mercury as cathode. Getting me? In the previous cases, I have discussed the electrode is inert, that is a platinum, that is inert. But now I am using the mercury as a cathode. As a cathode. It's a reactive. So what is the physical state of mercury? Can you tell me? At room temperature, mercury is liquid. Very good. So mercury is liquid. I cannot make its hanging electrode. So this is the mercury liquid, and connected to the cathode part, mercury is here. And I'm considering here anode is made up of the platinum positive. And in between, I have a Na positive, Cl negative ion, and H positive and OH ion. Right? First of all, I talk about the anode part. Anode means the positive part, right? At the positive, Cl negative ion and the OH ion. Yes, same beaker. Yes. Which will be discharged? Which will be discharged? Cl negative ion or the OH ion? Cl negative ion. Very good. Why chlorine? Why not OH ion? Why Cl negative ion? Why not OH ion? Akash? Neha? Yes, preferential discharge theory. And according to that, chloride require less potential to get discharged as compared to the OH ions. Right? Now, at cathode, when we are using here mercury, one possibility is H positive ion can gain electron and become H2 gas. Other possibility is sodium ion can gain electron. Which will take place? Why hydrogen? Yash, Neha, Shrija. Why H? Why not sodium? More reduction potential. You're right here. But that is a very common case. But in case we are using mercury, you know that sodium, if reduced, will make an amalgam with the sodium, with the mercury. Sodium mercury amalgam will be formed, alloy will be formed. So we say when we use the mercury here, the discharge potential of the sodium ion, is less than the discharge potential of the H positive ion. Discharge potential of sodium ion is less than the discharge potential of Na positive ion. So sodium will be deposited, not the hydrogen. Right? This will not take place. So this sodium will now get dissolved in mercury and it forms here NaHgX. Getting me? You have to remember this, Yash. You have to remember this, that in case you are using mercury, then this mercury amalgam will be formed. But this mercury amalgam, sodium mercury amalgam, again react to the water to produce a NaOH and H2 and mercury special. So again the product is same. Product is same. Hydrogen gas. Right? Product is same, that is hydrogen. But the mechanism is different. Yes, only for mercury. In our syllabus, we have only the mercury case, not anything else. Are you getting me? Yes? Okay, fine. Now, we discussed about the electrolysis of the acidulated water and the sulfuric acid using platinum electrodes. Under two conditions. One, normal current density and high current density. Two cases I will be discussing here. Number one case. I am discussing here the normal current density when the sulfuric acid is dilute. It undergoes complete dissociation, right? So at anode, either the water will get oxidized or the sulfate will get oxidized. So which will be getting oxidized here? The one which has a higher oxidation potential. You can see the one that has a higher oxidation potential will be oxidized. See here, which is the higher oxidation potential? See these two values here. Water. So OH ion, water will be oxidized, not the sulfate ion. And at cathode, the water will be undergoing reduction. Getting me? Any doubt till now? Overall equation we can add just here. Right. But in case I am using here a high current density, it means the sulfuric acid is 50% H2SO4. In case it is a concentrated, it does not undergo complete dissociation. This is the structure of the sulfuric acid here, H2SO4. In case it is a concentrated, only this is dissociated, not all. So it gives here H positive and HSO4 negative, right? So at anode, we have two things. Along with the sulfuric acid, we have water here also, H positive and the OH negative ion. Out of these two, which will be discharged? Out of these two, HSO4 negative ion and OH negative ion, which will be discharged? That depends upon the discharge theory. We know that discharge potential of the HSO4 negative ion is less than the discharge potential of the OH negative ion. So OH ion will not be getting discharged. Yes, OH ion will not be getting discharged. HSO4 will be getting discharged. This compound is called as a peroxodisulfuric acid. Is called as a peroxodisulfuric acid. Peroxodisulfuric acid, right? It is also called as a Marshall's acid, right? And at cathode we have hydrogen only, because here both of these are hydrogen here, and it undergoes reduction to form here H2 gas. Any doubt here? And then this sulfuric acid, peroxodisulfuric acid, undergo hydrolysis to give sulfuric acid and H2SO5. This compound is called as a Carrot's acid. Do let me know if you find any doubt here. Yes, any doubt here? No doubt. Good. Now we discussed about the electroplating, the application of this application of electrolysis. Number one is the electroplating. First of all, I'm discussing electroplating. How do we do that, right? Suppose I have this iron piece, and here is a platinum electrode, and on this iron piece, I want to electroplate silver. So I take here silver nitrate solution. Let it be. This is made negative cathode, and this is made positive. H positive and the OH ion. Silver nitrate has been dissolved in water only. So we have here silver ions and NO3 negative ion. In here we have water, H and OH ion. So I'm passing current here. I'm passing current. It's a negative terminal here, it's a positive terminal here. So out of the silver ion and the H positive ion, which will be reduced? Can you tell me? And I will discuss about the galvanization later on. See, silver reduction potential. See, the silver reduction potential from the electrochemical series is 0.80 volt. And the reduction potential of hydrogen is 0 volt. Now you tell me which will be getting reduced? Silver, right? So on this, the silver will be deposited, right? And out of the NO3 negative ion and the OH negative ion, which will be discharged first? OH ion, right? So OH ion will get discharged to form what? If OH ion get discharged, it forms water, oxygen, and electrons. So oxygen gas will be liberated here. Are you getting me? Right. So that is the electroplating. Electroplating means we are covering a particular metal with another metal. We are making a layer of it. Second application now I'm discussing is the electropurification. In the electropurification, what we do, we take up, let it be copper, and this is an impure copper. This is impure copper. Wait a minute. Right. Here I take up a pure copper, and here we have impure copper. And now we are connecting it with a battery. The pure copper is connected to the negative terminal, and impure copper connected to the positive terminal. And here we have copper sulfate solution. It's the electrolysis of the copper sulfate using the copper electrode only. Using the copper electrode. One pure, other impure. First of all, we discuss about at the cathode. At the cathode, one possibility is copper ion can gain electron and become copper here. Or it may be the H positive ion can undergo reduction and form here hydrogen. Now let me know which will be getting reduced. Yes, now let me know which will be getting reduced here. Copper. Why Akash? Why copper? Why not hydrogen? Copper has a higher reduction potential. Yes, very good. So reduction potential of copper is 0.34 volt, positive value. And reduction potential of hydrogen is 0 volt. So copper has a higher reduction potential. So from this copper sulfate solution, the copper will be deposited in the pure copper. Are you getting me? Now, we talk about at the anode. Everybody clear? Everybody is clear? Right. At the anode, one possibility is sulfate ion may undergo oxidation. It forms a sulfur dioxide and oxygen and 2 electron. One possibility. Second possibility is the OH ion may be losing electron and form here water and oxygen and electrons. Other possibility is this copper solid undergoes oxidation. The three possibilities. Out of these three, that one will take place which require minimum potential, minimum energy. So from here, the copper ion come into the solution. Means this take place, this do not take place. Getting me? Are all of you getting me? Right. Right. So copper will be deposited over. Copper is coming out to the pure copper and impure copper, and will get deposited on the copper here. Right. So here, the whole of the impure copper, from the impure copper, copper will come out and get deposited in the pure copper. Impurity will be left over here and that settle down. We call it as an anode mud. Shrija, I told you by sign convention, negative is cathode and positive is anode. In the electrolytic cell. Electrolytic cell means when we are passing the current. But in electrochemical cell, it is just the reverse. In electrochemical cell, it is the reverse. Right? Anode mud, that is impurity is left over the copper. From the impure copper, pure copper has gone here. From the impure copper, pure copper has gone to the pure copper. And the impurity that is left over here, that settled down, and that is called as anode mud. Is that clear? Right. So out of these three options here, which one will take place? Which one will take place? The one which will require minimum potential difference. The one which require minimum potential will be, right? Everybody okay? Getting me? Shraja, do cathode and anode made of different substances? No, Shraja. Basically, both are. Basically, it depends upon how do we connect them to the battery. See, the negative terminal and the positive terminal. It depends upon the how we connect to the battery. When you're passing current to the solution, it's an electrochemical cell, and negative terminal is called cathode, positive is called anode. Very simple. I hope you're getting me, right? Everyone getting me? All right. So that was the qualitative part. And now I will be discussing about the quantitative part, right? For that I will be discussing here the Faraday's laws. Now students, do let me know if you find any problem till now. You can ask me, because that is the qualitative part is over. And now we're going to discuss about the quantitative part. Very, very important. Here we will be discussing some numericals. But before that, you should know what products are formed. Yes, everyone, it's clear? Anirudh says no problem. Everybody else? Okay, fine. No problem to anyone. Okay. Even if you have, and later on in the class, you realize, please ask me. Right? I can discuss each and every problem. Right? We have enough time. We have enough all resources we have, right? So I can discuss each and every problem. So, can you tell me if I am doing the electrolysis of sodium chloride, at which electrode this will take place. The one that I have written here. Anirudh, uh, it will take place at, see what is happening, reduction or oxidation. What is happening, reduction or oxidation? Reduction. And reduction takes place at cathode or anode? Reduction takes place at cathode or anode? Cathode. So this is going to take place at cathode, right? Okay. Now, quickly, can you read this equation quantitatively? Can you read this equation quantitatively? Please type in the chat box. How do you read this equation? Please type in the chat box. I'm waiting for your answer because that is very, very important here. One sodium ion losing, not losing. Yes, it is gaining. Okay. Anirudh says sodium ion gain electron and form sodium. Anirudh, you are giving me the qualitative part. I'm asking you to give me the quantitative part. Ex Explain this equation quantitatively, quantity wise, not the quality wise. One sodium ion gaining one electron to form one sodium atom. Yes, yes, in terms of moles actually. Okay, I'll now start, right? All of you please focus here. I say 1 mole of sodium ion gain 1 mole of electrons and produce 1 mole of sodium atoms. Are you getting me? Yes, are you getting me? Right. So what is the amount of the 1 mole of sodium in weight? In terms of weight, what is the 1 mole of sodium? What weight is equal to 1 mole of sodium? 23 grams. Very good. It means 1 mole of electron means Avogadro number of electron. Am I right? Right. What is the charge on 1 electron? 1.602 10 to the power minus 19 coulomb. Am I right? Getting me? So if I multiply with the Avogadro number, that will give the total charge. This comes out with 96500 coulomb. So if I provide here 96500 coulomb to the 1 mole of sodium ion, 23 gram of sodium is deposited. I can read the equation like this. Right? I have neglected here negative sign. I am basically counting the charge by magnitude, how much charge we are providing, right? So I had neglected a negative sign. So I can say this is equal to 1 Faraday of charge if given. It will give 23 gram of sodium. Am I right? Getting me? So if I provide here 2 Faraday of a charge, how much amount of sodium will be deposited? 46 gram. Very good. If I provide here 3 Faraday of a charge, how much sodium will be deposited? 69 gram. Very good. If I provide here 0.5 Faraday of a charge, how much sodium will be deposited? Yes, 1 Faraday is equal to 965. 00, more appropriate you can write 111.5 grams, right? Okay. Now I can say the mass deposited is directly proportional to the charge given to it. More the charge I give, more the mass deposited. And this is the Faraday's first law. This is the statement of the Faraday's first law. That is, mass of the substance deposited at an electrode is directly proportional to the charge given to it. is a charge given to it, right? So I say M directly proportional to I into T. What is I? Can you tell what is I here? Current in amperes. Anirudh, make it clear. Current in amperes. T. What is T here? Time in what? It's not temperature. It is T time here. Time in seconds here. And so I write here M is equal to some constant I must write here, that is equal to Z. Z is IT. So M is equal to ZIT. Z is called as electrochemical equivalent. Z is called as electrochemical equivalent. Yes, are you getting me, everyone? That is called electrochemical equivalent. Do you know what is electrochemical equivalent? Do you know what is electrochemical equivalent? Let me know. Okay, I'll discuss. Don't worry. If I provide here 96500 coulomb of charge in this sodium, this case, 23 grams of sodium is deposited. If I pass here 1 coulomb of charge, I will get 23 upon 96500 grams. And this is called as a Z value for sodium. Means mass deposited by passing 1 coulomb of charge. Mass deposited by passing 1 coulomb of charge is called as electrochemical equivalent. It will be different from different element. Suppose I say I have a magnesium here. So I can say 2 into 2 here. Getting me? This equation you're getting me? Can I say is equal to 2 into 96500 coulomb? If I pass here, that will give 24 grams of sodium, magnesium here. Are you getting me? Yes. So with 1 coulomb of charge, how much magnesium will be deposited here? 24 upon 2 into 96500. This is the value of the Z for magnesium. It means for different elements, they have different value of Z. For different elements, they have different value of Z. Getting me? Right. Just go through this slide. Done.